Earth's interactions with Mars may affect the deep ocean. New research suggests that Mars' gravitational pull may be influencing Earth's oceans. Scientists analyzing sediment samples from the deep ocean discovered a pattern in which deep-sea currents waxed and waned. This cycle occurs approximately every 2.4 million years and, according to scientists, it can only be explained by the gravitational influence of the red planet. In a new study, scientists from the University of Sydney and the Sorbonne University looked at the impact of climate change on ocean circulation. They wanted to determine whether deep-sea currents are getting stronger or weaker as the climate warms, and whether this knowledge could help model future climate impacts. In their work, they used geological data from the deep sea. They found that the strength of deep-sea currents varies in cycles lasting 2.4 million years. According to the study authors, these changes occur as a result of the interaction of the orbits of Earth and Mars. The results and description of the research were published in the journal, Nature Communications. Mars is a small planet, and although it is relatively close, about 60 to 400 million kilometers away, its gravitational influence on Earth is small. We know that other planets can influence the Earth's path around the Sun, changing its shape. This is the case, for example, with the Milankovitch cycles, named after their Serbian discoverer. He calculated that the parameters of the Earth's orbit change over time, including the eccentricity and inclination of the ecliptic, as well as precession. All this is caused by the gravitational influence of the planets of the Solar System. Milankovitch cycles coincide with ice ages, occur over tens of thousands of years, and arise mainly from interactions with Jupiter and Saturn. The gravitational fields of the Solar System's planets interfere with each other, and this interaction, called resonance, changes the planet's eccentricity, a measure of how circular their orbits are, said study co-author Dietmar Müller of the University of Sydney. Milankovitch cycles were confirmed in 1976, when scientists discovered that they left a trail in sediments at the bottom of the ocean. A group of scientists from Australia and France also analyzed sediments from the ocean floor. She tried to determine whether deep-sea currents change as the climate gets warmer, or if they slow down. The researchers used data collected while drilling in the ocean floor. This data came from hundreds of places around the world and had been recorded for over half a century. A pause in sedimentation indicates vigorous deep-sea currents, while continued accumulation of sediment indicates calmer conditions. Combining this data with advanced analysis of spectral data allowed us to determine the frequency of breaks in sedimentation over 65 million years, said Dr. Adriana Dutkovich from the University of Sydney, lead author of the study. Researchers used records of sediment from the ocean floor to check the links between its accumulation or dispersion and changes in Earth's orbit. They found that the strength of deep-sea currents varies in cycles lasting 2.4 million years. We were surprised to find cycles lasting 2.4 million years in our deep-sea sediment data. They can only be explained in one way. They are related to the interactions of the orbits of Mars and Earth, AWoCQ admitted. For Earth, these interactions mean periods of increased solar radiation and, consequently, a warmer climate. All this in cycles lasting 2.4 million years. The researchers noted that warmer periods correlate with an increased incidence of interruptions in the deep-sea sediment record due to more vigorous circulation in the deep ocean. This result is quite unexpected because indications from ocean observations and models suggest that the current Atlantic circulation system that produces the Gulf Stream stream may cease to operate in warmer climates due to melting sea ice. On the other hand, in warmer climates, powerful storms occur much more frequently, creating sediment-mixing vortices that can reach even into the deepest parts of the ocean. This may mean that the oceans are a bit more resistant to climate change than we thought. Our deep-sea data spanning 65 million years suggests that warmer oceans have more vigorous deep-sea circulation. This will potentially prevent ocean stagnation, even if the Atlantic meridional overturning circulation (AWoCQ) slows down or stops completely, AWoCQ noted.
Pas de soleil, pas de soleil, pas de soleil, pas de soleil.